Welcome to the Structural Engineers Association of California's training course for its Earthquake Performance Evaluation Program. This course is sponsored by the SEAOC Post-Disaster Performance Observation Committee, and it's the first module that describes minimum qualifications for the training and course objectives. The minimum qualifications for this training are membership in SEAOC. Trainees need to be certified by the Safety Assessment Program of CalEMA, that is ATC 20 training, and you're required to have a civil engineer license with building design emphasis, and it's preferred that you have a structural engineer license. The duration of the course is going to take roughly an hour, and it has 8 modules. This is the first of those 8 modules. And we'll be summarizing in this module the course objectives, and other modules will be getting into a description of an exercise scenario that highlights deployment procedures that are likely to occur after future earthquakes, and safety precautions and equipment that you should be planning to bring in the event that you are deployed. And it will familiarize yourself with evaluation forms and showing how those forms are filled out for common building types in California. And we'll be summarizing other phases of operations within the Earthquake Performance Evaluation Program and the role of the Post-Disaster Performance Observation Committee. And this will lead to steps for you to obtain a credential so that you can participate after future earthquakes in this program. The mission of the program is to provide consistent and detailed efforts to collect and archive observations of the behavior of building structural and non-structural systems, as well as their occupants and contents, to accurately distinguish variations in performance and help SEAOC and others explain through science these. The objectives of this course are to describe why EPEP is a worthwhile activity for SEAOC members, and to develop your proficiency as a trainee with EPEP's deployment procedures, its evaluation forms, how data will be shared, and how more detailed evaluations will occur following future earthquakes. And we hope to get feedback from you as a trainee to identify gaps and ways to improve SEAOC's ability to help collect and evaluate performance data in the future. And this eventually leads to issuing a credential to trained volunteers. So why should we have an earthquake performance evaluation program? Our hope is that this will help calibrate performance-based earthquake engineering to improve performance objectives by collecting, evaluating, and publishing data about the performance of actual buildings in earthquakes. And this will help reduce uncertainties in performance, perhaps improve performance, by bringing the practical expertise of structural engineers within SEAOC to bear, augmenting the expertise that currently is deployed after earthquakes from EERI, peer, and academia. This effort should increase post-earthquake reconnaissance opportunities for SEAOC members as well. Well, what's wrong with our current practice? Well, past reconnaissance reports often look like this. We often will see a picture or two of a major building in a written report, perhaps with a close-up of the worst damage that occurred in the building and a brief description of the structural system and its performance. These reports are often issued several years following earthquakes, and often little is said about the functions or the occupant behavior, the casualties and losses that have occurred or downtime within these buildings. Why can't we simply tap the ATC 20 Safety Assessment Program tagging for more information or augment that? Well, the Safety Assessment Program is really designed to address the question, are structures safe enough to occupy? And this entails conducting rapid evaluations on the order of 10 to 20 minutes per building. And the Earthquake Performance Evaluation Program really has a different objective, with the focus on trying to answer how and why do systems perform as they do, and it might take anywhere from 30 to 120 minutes per building to gather enough information to help answer those questions.